All right, let's get started. Everybody got this paper?
Yes.
Okay. So, we've done trig, we learned trig, we've done circles, we've done sines, cosines, tangents, we've used the calculator, and whenever we use the calculator in trig, we're pretty specific about a setting on the calculator. Degrees, because we need it in degree mode, because sine of 60 is 60 degrees. But what the heck is the other option? Radian. So guess what we're going to learn today? Radian. So, on your piece of paper, here's what we'll do. This is my paper that looks like your paper. You guys cool with that? Mm-hmm. So, on your paper, let's put a nice big radian. Now, well, yeah, at the top, right? This is your piece of paper. You follow? So, radians and degrees are very similar. It's kind of like two different languages. I said yesterday, it's kind of like Spanish. Some of us speak Spanish. Some of us soon will be speaking in radians. Maybe Latin is a better example because, you know, it's just a little different. And speaking Spanish, also speak Spanish, but radians is just a little bit different, but it also has to do with degrees. And you don't need to draw this part, but degrees is how much you kind of open up an angle, how much you rotate. Let's just say 30 degrees. And there we go, that's 30 degrees. And that works great. And sometimes you do problems where that's really useful and really good strategy, but then sometimes you're in trigonometry, you go on to math analysis, you're taking calculus, maybe you're just taking some stats where you need to measure something, and instead of wanting to talk about the degrees here, you actually want to talk about this. This is something you learn in geometry. This is the arc length. This is the measure around the circle. And so radians is talking about the same thing. It's talking about a portion of your circle, but instead of talking about degrees, 30, 45, 60, 90, 75, or 90. 75 doesn't come after 90, maybe 115, whatever. It's been in my hands in a weird way. Instead, we're going to be talking about the kind of distance around the outside. So why do we call it radians? What's another word that kind of sounds like radians? Radius. So, when we're talking about this around the outside of the circle stuff, what is it called around the outside of a circle?
Circumference.
Nice. Heard a couple people that got that right. Circumference. Does anybody know the formula for circumference? It's not all that hard, but circumference is 2 pi r. That's a pretty simple little formula. 2 is obviously a small number. You don't necessarily need to write that down. This is your paper, so we're just kind of chatting for just a second. 2 is kind of normal. Pi is very strange. We've all seen pi before. We all did geometry. Does anybody know pi is what point what?
3.14.
Nice job. 3.14. Anybody know the next one?
5, 2,
3.14, 159. Now, what about this r? What is the r?
radius.
It is the radius. And what is the radius of your circle?
Length.
Who knows? Oh, right. That's a very good point. The radius of your circle is from the midpoint of your circle to the outer edge of the circle. But what is the radius of the circle? Who knows, right? It could be 20, it could be 100, it could be a million, it could be 2.5. Who really knows? Now, what we're going to talk about is the general case of these things. And just like we were doing last week, this week, we're just going to decide that our radius is 1. Because that makes everything super, super easy. So let's just imagine we have a nice circle with a radius of 1. So we can trade out our r for number 1. And what happens when we put a 1 here? What is 2 pi times 1? It's just 2 pi. It's just 2 pi. So, if you're thinking to yourself, Mr. Collier, I'm getting a little lost. Like, what are we doing? I haven't been writing much down. Here we go. If our circumference is 2 pi, well, that is exactly what radians is talking about. It's talking about your circumference as you go around the circle. And we just decided that our trip all the way around, our full circumference, is going to be 2 pi. Okay? So, now, on our sheet, let's draw a nice big circle. There you go. It can take up most of the piece of paper. Alright? This is going to be a big part. If you've already been drawing it, that's okay. You don't need to, but just, I would say make a relatively big circle, and then I'm going to take everybody's paper and show how good your circle is.
This is old.
I'm kind of happy with my circle, honestly. This is pretty, that's pretty solid work right there.
Yeah.
It obviously doesn't need to be a perfect circle. Colin, I think you're more or less straight. Take a piece of paper, write radians on the top, draw a circle. Now, what we've just decided, as always, let's go ahead and draw these nice quadrants in our circle. And we've been here before. We've been doing this. We've been talking about degrees. And where was the initial side? Where did we start? I'll give you, don't write this. What do we think? A, B, C, D. Where do we start?
C.
We start at C. That's our initial side over there. Cool. So that's the same exact thing. That is still going to be 0. So we can go ahead and put a 0 there. And what we just talked about, it got a little confusing, is that radians is the measure of the outside circumference, but that the whole circle, we could just say, has a circumference of 2 pi. That means when you do a full lap, instead of saying 180 degrees, you can say a full lap is 2 pi. And so here we go. We're starting radians. This is something we're going to have to be good at. We're going to have to memorize this. When you leave today, this is something you're going to know this fast. And right now it probably seems a little weird. Now what we want to do is figure out what are some of the other places around the circle. Because obviously when we do our degrees, we know that it goes 90, 180, 270, 360. And now we're speaking a different kind of language, but we still want to know what are those quadrantals, what are those corners. I like to think about my corners. What are those corners of the circle? So let's skip over 90 right now, and let's think about this one that's on the opposite side. Now this is actually a really easy one. Does anybody know what we would call this side over here? So normally 180, in degree mode 180, but we went in our brain and we change it over. What did we say? Somebody said that, I think. Pi. Over here is gonna be pi. Now, I didn't give that answer away. And I hope we're not Googling it. I mean, if we're Googling it, this is what it is, but how on earth did they come up with this side over here being pi?
Isn't pi 3.14, right? How would that be 3.14?
So don't think about pi as 3.14. Pi is just like pi. We're just gonna leave it as pi, right? But what we do know is that a full lap around is worth 2 pi. So how much do you think a half lap is worth? Only 1 pi. And so that is where the pi came from. Now, normally a trig teacher or geometry teacher or whatever would say like, oh, wouldn't it be nice if the whole circle was a whole pi, right? Like that would be really nice, but that's just not how it works. The whole circle is 2 pi, so half the circle counts as 1 pi.
So we're thinking like 2 halves of a pie. Because it's
Yes,
half is a pie.
1/2 is a pi, And then if you have 2 halves, then you have 2 pi. It's one of those things where you kind of get this like weird 1s and 2s. But now let's go figure out our 90 degrees.
Good question.
Again, think about it really simple. 90 degrees. How many pies is that worth? A full lap is worth 2 pies. This is half of a pie. Because what we have here, this is a pie, right? And down here, this is a pie. It's very strange. Okay, that means that up top here, we're gonna have pi over 2. Because it is half of a pie. Now, bad news, fractions. Fractions, fractions, fractions.
Okay.
Crazy fractions, weird fractions. Fractions are coming, okay? And let's get our last little quadrantal, our last corner here. How many values of pi would we have if we went this far around?
1
I heard somebody say 1.5. But let's make it that a fraction instead of a decimal.
Okay.
Instead of 1.5, the fraction would be.
Let me know, Mr. Collier.
So we know that this piece right here, right? That's a half, right?
That's another half. That's a whole pie and a half.
What is 3?
So that's a whole pie and a half. Or we could say 1, 2, 3. 3 halves. So down here we're gonna say 3 pi over 2. 3 pi
Is this
over
whole
2.
pie analogy working? I wanna get this working.
I know, it's a little funky. Sometimes the spatial visualizers are like, oh, okay, cool, that's a half pie, that's a quarter pie, that's a this pie. Some people, it's not quite going quite so. That's okay, that's okay. Now, let's also throw on here our quadrants. Okay, I got a phone call. Quadrants, put your quadrants 1, 2, 3, 4 up there.
So, never really been a big pie. I only like half a pie. Sweet potato.
So that's, is that 2?
Did you hear that there?
Did I not ever come to class?
No.
Like
She was here, but I think she left.
I don't like yams either. No, he said sweet potato.
Yeah,
pie.
I've never done it.
Last name Bartholomew, right?
Yeah.
It's to be cool. Yeah, it's not really cool.
What is that? Dessert pie?
Sure, I brought those
Dessert pie,
in.
it's like kinda like
She may have been taking photos, leaving, I don't know. Now, here we go. Then we put our quadrants up here. Quadrants. 1, 2, 3, 4. Now, here's the first way I'm gonna challenge you. I'm gonna write a number on the board over here, and hopefully in pencil, I want you to try to place it into this region if you think it goes in quadrant 1, or maybe into this region. So I'll give you a nice head start here. So where do you think that pi divided by 4 would go?
You're right.
So this is a quarter of a pi. Think about this in terms of fractions. Is that bigger than 0? Yeah, of course. Is that half of a pie?
No, half of a half.
No, it's not. So a quarter of a pie is in quadrant 1. Because it's not quite all the way to a half of a pie. So in here, I'm just gonna put pi over 4. I'm not really worried about where exactly it is. Pi over 4 is one where we could maybe say, oh, it's the perfect middle, but we're not gonna worry about that too much. Okay? Let's do another one together. Let's do another one together. Okay, what do you think about, what if I said 10 pi 11ths? We just make up a fraction here. Now think about it like this. Whoa, that's the craziest, scariest fraction I've ever seen. So just relax for a second.
Fourth quarter.
Is that a full pie?
No.
It's not quite a full pie, right? It's 10 slices out of 11. And remember, a full pie is only halfway around. It's not 2. So where do we think 10 pi 11ths would be? quadrant 2. Into quadrant 2. 10 pi 11ths. And let me walk you through that one more time, because I see a couple of frowns, a couple of, those like stars and question marks popping up over the Looney Tunes heads. Not a big deal if you're thinking to yourself for just a second, whoa. Don't worry about any of this stuff. Don't worry about the pies. Don't worry about the circle. Just think about 10 and 11 for a second. Just think about 10 and 11, all right? 10 is not quite all the way to 11. And that means it's not quite all the way to 1. That means it's not quite getting all the way to 1. And this is where we get to 1 pi. That means I'm going, but I'm not able to get all the way to 180 degrees. Not that we're doing degrees anymore. So that has left me into quadrant 2. Okay? So now, I'm gonna give you one. I'm gonna give you maybe just a little bit of time. See how you do with it. Okay? Let's go with 7 pi 6ths. Think about it for a second. Take your time. Don't really worry about the pi too much. Just look at the numbers. Hold on for just a second. Look at those numbers. If I think about that fraction, is that bigger than 1? Is that less than 1? Where does that end up going? And then can you put that into quadrant 1, or quadrant 2, or quadrant 3, or quadrant 4? I got a couple people throwing up the old 3.
Oh.
That would be correct. This is in quadrant 3. This is in. Now again, just think about 7 over 6, right? This is a pizza with 6 slices, but we've got 7 slices. That means we got more than a whole pizza, right? We're past 1 pi. We're past this point. If you're thinking to yourself, this is crazy, I bet a lot of it has to do with 1 pi is right here, which is halfway around the circle, which is just a little bit hard to wrap our head around. But think about the number, think about the fraction. Okay, so what if we had something like this? What if we had something like 7 pi 4ths? We just had 7 pi 6, now we have 7 pi 4ths. Is the top number bigger?
Yeah.
So it's bigger than 1. It's definitely bigger than 1, right? This would be all the places where the bottom number is bigger, where we don't have quite a full pi. But now we've gone past it. We have 7 pi 4ths. Now how do we decide between quadrant 3 and quadrant 4?
Because we just got 7 over 6. Right?
What did you say?
We just got 7 over 6, so it might be a little bit lower.
So we just got 7 over 6. If it's kind of related to that, maybe it's lower.
It's in 3.
So again, think about this.
It's not black and white.
This is where 3 pi halves is, and that's kind of like where 1.5 is. Remember, we kind of said 1.5 pi, but I was like, we like fractions because we want to get our brain working in fractions. So this is like 1.5. That's kind of our area. What do we think? Is that going to go in quadrant 3 or quadrant 4?
3, 4, 3.
A couple 3s and a couple 4s.
Just 1 3/4, just about.
It's in 4. It's in 3.
So let's do this. If this right here is 0, that's like it has 0 out of 4. We agree with that?
Yes.
So how many is this?
1.
Well, this is 1, which is how many out of 4? This would be 4 out of 4. Okay? How many would be a full 2 laps?
8 out.
8 out of 4.
But we have 3 out of 4 left.
And we have 3 out of 4
So that's
left.
just a little bit before half.
So, let's break this all the way down. We've got 0 out of 4 here.
Okay.
We've got 4 out of 4 when we make this lap. We make it all the way back, we would get to 8 out of 4.
Okay.
What is in between 4 and 6? 4 and 8 is 6. Dang, I've spoiled it for you guys. This would be 6 out of 8.
Out of 8.
6 out of 4. Oh my god, Mr. Carter, come on. And we have 7 out of 4 for this question. So we should be in quadrant 4 for this question. It should be number 4 for this question. Quadrant 4. This was 7 pi 4th. Alright, so how can we come up with a way to do it? Because again, some of us are gonna be pretty good at looking at this, visualizing it, thinking about it. Here's what we can do. Let's take a calculator and let's just type in 7 divided by 4. And when you type in 7 divided by 4, you should get a decimal. And what decimal do you get? 1.75. Does that make it more clear why we're in that 4th quadrant?
Why you ain't telling me that?
Because it's a half, a whole, 1.5, 2. And 1.75 would be in between 1.5 and 2. Right, so that, you know, I'm not gonna say you're gonna have a calculator for every single assignment forever. We do want to start to think about these fractions, but maybe this helps you kind of realize it a little bit better. So, what?
Even with 10 divided by 11, it comes out to 0.9, so that's right before the 1.
Right before the 1, exactly. Right. I mean, it's a good strategy for all these. So, how about this? Somebody give me a number?
8 divided
Okay.
by 9.
Alright, 8 divided by 9. Maybe you're at the point where you know the quadrant that fast. Maybe you're at the point where you gotta think about it for a second. If you're super stumped, maybe use the calculator, but I would recommend, can you try no calculator? Can you get it where it's supposed to be?
It's not the same thing as 10 over 11.
Yeah.
It's like the same thing.
It's very similar. It's an almost full pi. It's an almost 1 fraction. It's just a little bit short. And so you're right. The top number is smaller. It is also going to be here. 8 pi over 9. Sweet. Colin, I appreciate your help on this one. Anybody besides Colin want to give me another one?
5.
5.
No, wait. 9, yeah.
9. Okay. 5 over 9. So this one's a little tough. Because this one is not as obviously right almost 1. It's not as obviously right almost there. Is it quadrant 1, quadrant 2, quadrant 3, quadrant 4? Which ones can we rule out right away?
1.
It's definitely not 3 and 4. Very good job. Because it's definitely not bigger than, you know, if this top number is, it's definitely going to be on top. Now, sometimes here's a little bit of a trick. Is the top bigger? That means it's going to be up here. Or if the bottom is bigger, right? So you kind of think about that. Or actually, it's the other way around. If it's smaller. Come on. Man, 2 mistakes in one moment. No big deal. Here we go. We had 5 pi over 9. And that is a little bit tougher. Can we go into the calculator? I like to think about it. If this is going to be 9, half of 9 is 4.5. So 4.5 is kind of my splitter here. 4.5 is where pi half is. Am I going to be bigger than 4.5? Quadrant 2. Am I going to be smaller than 4.5? Quadrant 1. This is going to be quadrant 2. Quadrant 2. Did we type in our calculator 5 divided by 9? And it tells us, what, 0.555 or something like that? And that is more than a half. So that's going to be in quadrant 2. Now we've been really good at coming up with fractions that are in quadrant 2. Does anybody want to offer me another fraction? And let's not have one in quadrant 2. What do you got? Or let's do here first. 11 sevenths. 11 pi sevenths. Whoa. It's a tricky one to do without the calculator. Tricky one to do without the calculator. I see the top is bigger, which means it's going to be in the bottom, the opposite of what I said a second ago, cringe. But anyways, we're going to be down here somewhere. Do we think we're going to be in quadrant 3 or in quadrant 4? What is 11 divided by 7?
1.57.
1.57. And we know that 1.5 is right here. So for 1.57, we should be over here. It's not all that bad. 11
It's
pi.
a little tougher. That's
Without the calculator, it definitely takes some time to really wrap our head around it. You know, I would think half of 7 is 3.5. 3.5 plus 7 is 10.5. So since 11's bigger than 10.5, that can be really tough to keep track of all that in our head. Now let me hit you with something else. What about if we had negative
Oh no.
2 pi sevenths?
So we start in the fourth quadrant, like we usually do it.
So yeah, we go.
Degrees and radians, they're theoretically the same thing. All the same rules work. They're just different numbers, but for the same thing. So because this is a negative,
Quadrant.
it means instead of going around this way, we're just gonna go clockwise, and we're gonna go down this way. And obviously the top is much smaller. Did we make it all the way to half?
No.
No, we didn't. So negative 2 pi sevenths. Sure, that's down there in quadrant 4. So all of these things that we just learned with degrees, they all still exist in radians. Let me give you one more example here. What about if we had something like, that's not very good. Let me give you,
Negative 7 over 12.
how about 11 pi fourths?
1.
Now 11 pi fourths.
It's not quadrant 1.
2 seconds.
So let's do that labeling thing we did again. If we're talking about pi fourths, this would be 0 pi fourths. And then this would be 4 fourths. And then how many fourths would be over here? 8 fourths. And where is 11?
But
It's gonna keep going around.
It's gonna
Okay?
be a little bit.
What does this vocab word remind you of when you have extra laps on degrees? Like what about 550 degrees? Right? We saw some numbers like that. Dory's got it. Coterminal. Do you guys remember coterminal? Ayana, I hope you remember coterminal. You got that test coming up. Coterminal are degrees that end on the same terminal position, right? So you just add 360 or you subtract 360. So very similar. We have coterminal radians as well. You can have extra laps around. So if this is 0 fourths and then 4 fourths and then 8 fourths and then another one over here, this would be 12 fourths. And so 11 would actually be right here. And it would be coterminal with 3. Now we'll do coterminal later. Okay.
That's a lot.
Radians, where you're at right now, if you are thinking to yourself, whoa, radians, I don't know that I like this, that's probably a decent spot, okay? If you're thinking to yourself, I absolutely hate this and will never learn this, this is only the first day of the whole unit. We're gonna be doing radians basically for the whole rest of the year. So you will learn radians, you will get it, I promise, trust me. It starts with 0, it goes to pi, and it goes to 2 pi. So, really quick, here's my blank circle. How many radians would you say should go in this position here? Is this 0 radian? Is this 0 pi? Is this 2 pi? Is this 1 pi? Is this half a pi? This is 1 pi. Right? Let's just see if we can kind of create it from scratch. So what about this one? How many is in this position? That's pi over 2. And what about this position? Right, it's either 0 or it's 2 pi. Nice job. And so down here would be
3 pi.
3 pi over 2. I mean, already we learned that much, right? And we're just really what we're learning is not even all that much about radians. It's just about fractions and where these fractions end up between 0 and a half, between 1/2 and pi. Really good strategy, especially today, is to use that calculator, right? If you see something like, 8/11 and you think, ew, I don't really know what that is, type it in the calculator. You don't need to type in the pi, just type in 8 divided by 11. And what is 8 divided by 11? That's how you do it.
Oh, wait, what?
8 divided by 11.
0.72.
0.72, and that's gonna be past a half. So that's gonna be over here. This is gonna be in quadrant 2. Now, what if we had, it's a small little eraser. What if we had something like, one of those big numbers? What if we had, let's do 13 pi over 4. This is 13 is a very big number. Can somebody do 13 divided by 4 in their calculator? It's gonna be 3.25. Now, I know that this is 1/2, 1, 1.5, 2. 2 is a full lap around. When we used to do coterminal, we would subtract 360. What do you think you could subtract from this? 2. Minus 2 is 1.25. So we could think about this 13 over 4 as a 3.25. That's a little bit too many laps. Let's take away a lap. Let's think of it as a 1.25. And I see Josh has got it. This was going to be in quadrant 3. All right.
Don't erase it.
So is it good or not good to use calculator?
It's a good strategy, especially when you get the really funky ones. It's a good, idea to maybe think to yourself, ooh, maybe this would be quadrant 2, right? I wouldn't get super mega reliant on the calculator. Plus it just kind of helps you form those pathways in your brain, working with fractions. What do you got?
Why would you subtract 2 from it again?
Because how we used to add 360 and minus 360 for coterminal angles? Because when we add 360, it adds a lap and nothing really changes. It's the same thing here. This is 1/2. This is 1/2, 1, 1.5, 2, but 3 is even past
It's
that.
basically just like subtracting a 360, but it's 2.
Exactly. So that way, instead of having to think about it like 1/2, 1, 1.5, 2, 2.5, 3, 3,
Yeah.
we can just kind of take a whole lap off and keep it a little smaller. Okay, I've been talking enough.